Okay, today we are going to be doing work on simple machines. The reason you use a machine is not to reduce the amount of work, but it is to make the work appear easier by reducing the force that needs to be applied to the object you're doing work on. Okay? So in other words, if I take this 1,000 Newton object and I lift it straight up, force times distance is going to be equal to work, and that's 1,000 newtons times 1 meter equals 1,000 joules. Okay? Now, this is important. What we're going to call that is output. Output. When you're not using machine, we're going to call that output. So this is output. That's the output force. This is the output distance. This is the output work. Correct? Yes? So, what you're going to be using is a large force times a small distance. Correct? A large force and a small distance. This is equal to force output, and that's equal to distance output. Correct? Now you know that's true because work is force times distance. We're just simply defining that as output. That's without using machine. Now, what we'll do now is we'll use a simple machine called an inclined plane. And what I'll do is there's no friction yet, nothing. This is all ideal conditions, okay? Very important. So what I'll use is, I'll use a inclined plane to slide this box up the inclined plane. Now, we're not really going to be using the ramp physics yet with the normal forces, the Fn and the Fp. Don't worry about that yet. We're simply going to use this inclined plane to accomplish this goal. I want to put it right here. Okay, I want to put it right there. Correct? Yes? This is going to be the input distance. So it's either in or out. Output, input. Input is the work done by the machine. So if I know how much work, that's the work I want to accomplish. Yes? Correct? You get that? It's the same amount of work. Ideally, it's the same amount of work. So, if I say to you the work is 1,000 joules, okay, and I know that the distance is going to be 10 meters, what force am I going to use? What force am I going to use? In other words, what's my input force? Ideally, work output equals work input. That's all you have to know right now. We're simply starting this process by looking at ideal conditions. So if this is true, my work output equals 1,000 joules. Equals my distance, the input, yes, times my force input. So what's my force input based on what I wrote on the board? You can do this. Elvis? You don't know? Really? Really? Single variable equation? Really? I think you're not trying. Elvis, 1,000 equals 10x. You can't solve for x? You can do it. I know you can do it. What's the answer? What is it? What's x? 100. There you go. You see, I knew you could do it, dude. So it's going to be equal to 100 newtons. Yes? So I'm going to take that box, and I only need to apply 100 newtons. 100 newtons is like a 10 kilogram weight. In English measure, that's like 22 pounds. 10 kilograms. It's not bad. So if I apply, thank you for participating, I appreciate your support. So if I apply 100 newtons, I'm 1,000 newtons, 1/10 of it. So it's much easier, correct? Yes or no? So if I apply, this is my applied force. My applied force will equal 100 newtons. You see that? So we could say this. We could say, ideally, this is ideal, these are equal. This is the output. This is human. Right? This is machine. Correct? So if I say a small force times a larger distance. Correct? Can you see that on the board? Does that all come out? Okay. All right. So, let's review. Okay, let's review. Let's review. Output, the human part of the equation. Input. Input. The machine. Right? Ideally, the work input and work output are equal. The output is FO times DO, and that's going to equal the work output. The machine, when I use the machine, it's going to be the work input equals the work input equals the force input times the distance input, correct? And we know that ideally it's all equal, okay? You're making a lot of noise over there, you know that, right? You know that? Okay. All right, now, so I use the machine This is the machine side. I use a small force to move at a larger distance, but work is the same if it's ideal. End of conversation. You get that first. We simply defined ideal nature of a machine. You get it? You with me? Any questions? Anybody? Okay. So that was defining the ideal nature of a machine. Work input equals work output. Work output is the human element, FO times DO equals FI times DI. Elvis, you okay with that? Excellent.